Now we're going to see alkylation, alpha alkylation, but with beta dicarbonyl compounds. So if I have a beta diketone, so relative to this is alpha, this is beta. So that's a beta diketone. Because these hydrogens are more acidic and the pKa here is, say, 9, I don't need to be using LDA of our sodium hydride. I can be just using ethoxide or hydroxide. So here, for that alkylation, we're going to use, say that I'm using ethoxide. So sodium ethoxide. I didn't draw the counter ion. Removing one of the H's here, you're going to form this enolate, which is now resonance stabilized. So we're going to be drawing the resonance structure, which places the negative charge on the oxygen. Here we go. That. Of course, I can do it to the other side, right? We will have more resonance structures. So now for the alkylation, the second step, I will be adding, say, metal iodide. So just like we did in my previous example. And that is a great reagent for the SN2 step, because here we don't have a steric hindrance. So now I'm going to do an SN2 reactions, which is I'm going to form the double bond here, and I'm going to attack this carbon, and iodide will depart. So my alkylation product is now, I have a double bond here, and now I have introduced a metal group at the alpha position. So that is an alpha alkylation product. So this reaction is very useful in synthesis. Notice that we just had created a new carbon-carbon bond. There are several strategies to do that in organic chemistry. We can do SN2 reactions with cyanide, creating nitriles. That's one example. We can do in aromatic ketones. We can do Friedel-Crafts, alkylation or acylation. There are a number of reactions. And here we're going to be studying another way later, which is the aldol reactions. But for now, notice that when we're doing alkylations, we're creating also a new carbon-carbon bond. So this is now methylated at the alpha carbon. And now we can repeat that, because we can repeat the cycle. So here we did, and we can do it again. And one more ethoxide. Why? Because I still have one alpha hydrogen here. So I'm going to do the enolate again. And now I'm drawing this structure. Remember, I still have one H. Let's draw it just in case. All right, so we're going to be extracting this hydrogen. And this is my resonance structure. That's enolate. And I have a metal here that I had already introduced. But if I make it react, again, with metal iodide, or let's say, I'm going to change it. Let's say that I'm not using metal iodide, but ethyl bromide, just to see what happens, right? So ethyl bromide. So now I can do my attack, my SN2 attack, right? I'm doing this, and this is my alpha carbon, and I'm attacking my electrons are going to be attacking here, and lots of leaving group. So my final product will have now two substituents introduced at the alpha carbon. I will have a metal and an ethyl. So that is my final products. So you can use, and that's another new carbon-carbon bond. You can use then alkylations for that purpose.